In the last couple of talks, we've been discussing structure and materials and how fundamental that is in the making of architecture. But there's another aspect, another kind of physical consideration related to that that is equally important. It's important to know how the building is going to stand up and how it's firm, and firmness is a part of excellence in architecture. But it's also super important to know, wait, how are we going to build it? Because even if a concept is going to be great when it's all constructed, but it's either impossible to build or inefficient to build or expensive to build, it can completely ruin that concept. So in this talk, we're going to be looking at the impact of construction on architecture and design. So there are many different ways that we build buildings, and there are innovative construction processes, and there are standard construction processes, and there are very expensive and kind of customized construction processes, and there are very inexpensive and sensible construction processes. But I think if we start here by just thinking of what are the normal steps in a construction process, I think it helps us understand what the issues are. So I would say there are 7 kind of fundamental steps in a construction process. And they may be done in slightly different order, but generally they're done in a kind of sequence. And if you go out and look at a construction project, and there are plenty of them around in Austin at any time, you can actually sort of see those steps of the process at work. And often it's really fascinating to watch a building being built. Maybe that's just me as an architect, but I love seeing construction sites and seeing buildings being built. And but it's a fascinating process. It often involves hundreds, sometimes even thousands of people on a complicated construction site. And that's just the tip of the iceberg. There are other people fabricating pieces and parts of the building that are assembled on the site, so that it costs a lot of money, it involves a lot of human labor, it requires a lot of coordination, and that construction process is very, very essential in understanding how architecture is made. And good architects are thinking constantly as they design about how this is going to impact the construction process. So let me just walk through what I think are 7 fundamental steps in the construction process. The first step is site work. This may be a rural virgin site, it may be an urban site, but almost on any site there's going to be a little preparation of the site. It may mean leveling a steep site, it may mean removing or relocating some of the vegetation, it may mean demolishing an existing building. But the first step is really to get the site kind of ready for construction. The second step is then to put in the foundation. All the structural systems we were talking about last time, eventually they have to get those loads transferred into the ground, because the ground eventually takes the loads of the building. So there are many different kinds of foundations. Sometimes we, especially in Central Texas here, we often have crummy soil at the top. And we may have to drill through that soil and reach bedrock or better soil conditions that we can rest the building on. So sometimes we're drilling piers for foundation. Sometimes it may be as simple as maybe there's very good foundation conditions in the soil right there, and you can just pour a slab and rest it right there. So the foundation can be complicated or it can be simple, but the second step in construction process is then preparing the foundation to take the loads of the building. Then the third step is the structural system itself, exactly as we were talking about in the last couple of talks. Maybe it's a bearing system, maybe it's a bending system, maybe those columns in the bending system are going onto piers that take it down to the ground. maybe a bearing wall has a footing in the foundation that it's being placed on. But all of these are then interfacing a structural system onto that foundation. Then the fourth step is to provide thermal and moisture protection. And this is really now creating a kind of skin for the building, an envelope for the building. These days, this is hugely important. It's going to affect energy performance. It's going to affect comfort significantly. So thermal and moisture protection, providing that skin, that's a fourth step. A fifth step in the construction process is then going back in and placing partitions inside the building, subdividing rooms and spaces and functions, and responding to all of the internal needs of the building for bathrooms, for kitchens, for individual bedrooms, living rooms, dining rooms, whatever, or in an office space, maybe subdividing it according to what the work pattern's going to be in that office. But partitions are kind of a fifth step. A sixth step in the construction process is then putting in the systems of the building. And again, these days, this is huge. It's mechanical systems, that's air conditioning and heating, ductwork and distribution of that. It's electrical systems, it's plumbing systems. These days, it's Wi-Fi spots and things for digital technology. All of these systems of the building have to be integrated into it in the construction process. Then the seventh and final thing is then to put maybe some additional finishes on the building. That may be as simple as painting a surface that was there previously. It may mean putting on some elaborate wood paneling as a finished material. All of those finishes of the building, trimming out, covering up, making it finely crafted, all of that is a kind of seventh and final stage. So 7 steps: site work, foundations, structural system, thermal and moisture enclosure, partitions, systems, and finally finishes. Now, most construction processes have those in some form or fashion, but sometimes in innovative construction processes, those things can be truncated. So we're going to look at a few examples of innovations in construction methodology. It could be as simple as, when I was first beginning as an architect, when you framed a house and you made it out of wood, the carpenters would order the wood in certain lengths from the Home Depot or comparable thing back then. They would be delivered to the site, and the carpenters would cut each piece according to the drawings, and they would assemble them on the site. That's actually not so common anymore. It's much more common for some of those pieces to be prefabricated in a kind of factory environment. So if you're going to have trusses that make the gable at the top of a wood frame house, they're probably not going to cut every piece and nail it together on the site anymore. You're going to have some factory that's making what are called gang-nailed wooden trusses, and they're prefabricated in a factory somewhere. And those joints are not made with nails, they're made with nailer plates that are put on by a machine. And all of that is much more mechanized. It's able to be done in all kinds of weather because it's in a factory. That is a change in the construction process. And that kind of prefabrication is happening over and over. There's something we call these days SIPS panels, where that thermal and moisture protection is all assembled together. The insulation, the vapor barrier, the waterproofing, all of that is made in a sandwich panel that then is delivered to the site and assembled and constructed on the site. Those are alterations in the building process to make it more streamlined, more efficient, and less labor intensive. And then there may be some projects they've got a tighter schedule. We have to do this faster. And that may mean a different construction process because you're trying to do it much quicker. And the example we're going to look at next is a classic example of that, where in 1967 or so, they were preparing for the 1968 Hemisphere in San Antonio. This was going to be half of a World's Fair for the Americas. And as they got nearer the date of opening, they realized more countries are getting pavilions here. This is more popular than we thought it was going to be. And it looks like we're going to have a lot bigger attendance than we thought we were going to have. And we don't have enough hotel rooms in San Antonio to accommodate that. So can we build a significant big hotel right by the Hemisphere site? But we got to do it really quickly, faster than is normal in a construction process. So in that case, this is the Palazzo del Rio, the building that came out of that challenge. They only had a very short period of time to build this hotel. If they'd done the normal construction process, it wouldn't be finished in time for the opening of the fair. So instead, they altered that process. And what they did was they started by making these complete hotel rooms as concrete boxes. So away from the site, in a different area of town, they have these uniform formwork pieces like that, and they're pouring concrete around that box and creating a box like this, one for each hotel room. And they're putting in the glazing for the windows and the patio door right there. There you see all these little hotel rooms with the door to the hotel room there. This is half the corridor, the reinforcing rods that will connect to the other half the corridor and create the corridor down the center with hotel rooms on either side. So they're just manufacturing this in a kind of efficient and mass production kind of way. So that's getting some efficiency of time right there. And they in fact went so far as they just completed the hotel room in there. They put in the glass wall and the door out to the balcony, but they also put in the furniture and they attached the paintings to the walls, and they just did as much as they could in that factory setting to complete that hotel room and deliver it to the site. In the meantime, they'd been doing the site work and the foundation and the core of the building where the elevators would run right there. And then they're prepared to then bring those boxes out and stack them up. But now we've shortened the amount of time by doing the site work and the foundations and essentially the structural system of the core, concurrent with, at the same time as they're already doing the finishes and the plumbing and all of that for the hotel rooms back in the prefabricated factory. So here they're delivering one of those boxes to the site. They stack them up. This is one side of the corridor that's been completed there, and that half the corridor sticking out. Now they're stacking up this side, connecting it to that, and eventually just stacking box on box on box. The surrounding of the hotel room is the structural system that's stacking up there, and eventually they make the whole hotel like that, and they did it in a record 11 months, which it normally would have taken maybe 2 years, even more, to do that. And they were there and available and open when Hemisphere opened. But it was that construction process, that innovative construction process, that enabled that to happen. Now, this is a curious thing to me. I remember when that was done and I was blown away, and that just seemed like, whoa, that is the wave of the future. We're going to be doing prefabrication like that all over because that's so efficient. But that actually didn't happen. They did a few more hotels like that by producing the hotel rooms in a factory and floating them outside of remote islands in the Caribbean, where it'd be very difficult to build. But in some exotic instances like they did that. But these days we're getting hotels built all over Austin, and nobody's prefabricating hotels like that. And it's been, I don't know, I don't understand why there isn't more innovation in that construction process. But curiously now, not for schedule, but for price, we're beginning to get more of that kind of innovation. And there's a project here in Los Angeles called Hope on Alvarado that is just being completed in 2020. And it is, again, the same notion, but now it's for low-income housing. So this is being done for price and not for schedule. But these boxes are being made in China, and they're essentially the same technology as a container, a shipping container. They're not shipping containers. They were custom made for this project, but they're using the same technology as shipping containers, and they're being made by a factory in China that makes shipping containers. But they're again making all of that there and putting in the plumbing and the wiring and the accoutrements in the rooms and so on. And they're shipping them over from China across the Pacific to the port of Los Angeles. And then they're bringing from the port of Los Angeles into this neighborhood and making low-income housing out of that. And there you can see one of those units like that. And they're just bolting through these holes right there, just assembling them together like Tinker Toys and making this housing environment. And you're able to, on the inside, open them up significantly and make really beautiful, gracious rooms. But using the module of a shipping container and transporting them in the same way they transport shipping containers and using all of that technology in order to be able to get economy in this building. So those are innovations in the building process. There are lots of other innovations happening now. Whether they'll dominate the marketplace in the future, I don't know. But we have 3D printed buildings that are being experimented with right now. We have a lot of interest in digital fabrication. Dell Medical School, the HLB building here on campus, all of that stonework was digitally fabricated so that it was mechanized, and the architects did drawings that went directly to a robotic machine that is manufacturing that, and it's able to produce all of that stone in a very customized kind of way, quite inexpensively through digital fabrication. So all of these things are constantly mechanisms for advancing the field. I want to just, for the rest of the time in this talk, discuss how in a single building, how fundamental the construction process is in allowing the building to reach its full aspirations. And in this case, we're just going to walk through a Gothic cathedral. And nowadays, we don't think of them being innovative in terms of construction process, but it was absolutely essential. They had to innovate. In order to build the kind of thing they aspired to, they had to not only use interesting and innovative structural systems, but they had to figure out how to make it and how to use the mechanisms they had at hand to be able to design the kind of building and build the kind of building they wanted. So in the case of the Gothic cathedral, these were, as we've mentioned before, these magnificent, huge constructions that were often in relatively small towns. This one's in Amiens, north of Paris. It was a small town at the time. And in medieval times, they're building this magnificent construction amidst really a tiny, tiny little village there. And it was, again, just incredibly challenging to do that. This is a high Gothic cathedral. It was done 1220 to 1406. So it's this late Gothic period, one of the last great Gothic cathedrals in France. And so they're sophisticated. They know how to do this construction process very well at this point. So let's just walk through how they're doing this. For one thing, they've got these big aspirations. They want to have a masonry building, and that is means we have compressive loads and we've got a bearing structure. And yet at the same time, they want to open up these big windows and have lots of natural light inside the building. So you can see in that photo right there how much glass there is in that wall. But that's got to be a bearing wall that's carrying those loads from the roof down to the ground, and opening up that much glass, that doesn't work with a bearing wall. So they've innovated and created these flying buttresses where those loads are taken out to these piers out here and carried down to the ground there in order to take the load off of that wall and allow it to have much more glass. So that's a big challenge, and it's a big challenge to build. This is those flying buttresses, as you're seeing right there, carrying those loads out and down into the ground. And all of that is in order to enable this big, open, light, airy, tall space inside the building. So it's one thing to imagine what that's like when it's finished. It's another thing to think, whoa, especially in medieval times, how the heck do we build this? So let's just walk through how they're making these magnificent cathedrals and the building process that was necessary to do that. So they started in a very conventional way. They would have cleared the site. There you can see the kind of building that existed around, these little 1- and 2-story buildings. They would have cleared the site, built the foundations, actually a crypt down here where the foundations are, and then they start to build up. And as long as you're building masonry and you have scaffolding, that's a pretty normal way to build masonry. They start out with one kind of limestone that's very dense and very resistant to moisture. So where it hits the ground, they're using this darker limestone that's being used for the foundation and up to a certain point. And then they're transitioning to a lighter and more porous limestone that's more beautiful, but where it doesn't have to contact the moisture of the ground. That limestone is fine. So we're building up, we're putting in scaffolding, we're taking the stones up, we're laying them up in a kind of normal way. And up to about 4 or 5 stories, that worked well with their normal construction process in medieval times. But after you get up to a certain height, you can't build the scaffolding out of the kind of wood they have in that part of the world. They have wood, but it's small, sticky kind of wood, and you just can't build scaffolding over a certain height. It begins to collapse, and the weight is too much. So they have to innovate, and they figure out a way to make the scaffolding come off of the masonry wall they've already built. They plug it into that wall, cantilever it out here, and then in order to get the stones up there, they build these little spiral stairs, and people are trudging up here, carrying the stones, giving them to the masons on these scaffolds that come off of the stone wall, and you can continue to go higher and higher and higher with the stone wall. There are probably some of you who've gone to a Gothic cathedral, and maybe you paid your couple of euros and had the right to walk up to the top of the cathedral. You're probably going in these little spiral stairs like that. Believe me, they were not made for tourists in the 21st century. They were just construction process devices for getting the materials up to the upper portions of the building. Sometimes if there were big windows, they had to have much more elaborate scaffolding, and that would have to be designed as part of the building process. So they're building up and up and up, and now they're able to go a little higher because of that building process innovation. But now there begins to be the question, well, wait, how do we get the truss up at the top? Now they are going to get heroic big pieces of wood, often from a long distance away, maybe Germany or maybe Lebanon, and they're building these big trusses up here. But wait, how do you get it from the ground down here way the heck up there? This incredibly heavy truss. So again, they had to have a building process innovation. They kind of prefabricate the truss down here on the ground. They have joints that are mortise and tenon where they dig a hole and they stick a tongue through it and then they pin that connection. But that makes it so that they can disassemble it. They can assemble it on the ground and then disassemble it and take all those pieces up one by one and then reassemble it up at the top. But even then, the weight of those pieces is huge, way more than 1 or 2 people can lift. So they have all kinds of pulleys and hoists that they're lifting that with. And the mechanism, of course, they don't have any machinery, but the firepower for lifting that begins to be this wheel. And you get a little guy inside that wheel, and just like a gerbil in its cage, the guy is running inside that wheel, and that powers the hoist, and that lifts these big pieces up to the top of the building. And then very precariously, they're reassembling them to make that big truss at the top up there. So another big innovation there. So finally, they've got all that up there. They're having to build these flying buttresses that go out from the side there, as we have talked about before. An arch is a fantastic structural shape when it's complete, but until it's complete, it's worthless. So you have to build centering like this out of wood, and then you're taking those wood pieces, putting them up here, and then building the masonry on top of that piece. And you get that absolutely completed, and then you take that piece of formwork out, move it to the next pier, build it, complete the arch, take the centering out, move it to the next pier, and that goes over and over and over in the construction process. And the same goes for all of the arches in the building, which have to be built with centering first, or formwork there, and then the arch completed above. Maybe one of the most challenging things is way, way, way up at the top of that cathedral are these beautiful groin vaults, and they are stunning. But wait, how do we make those masonry vaults way up there? And what they ended up doing was making this centering, like you see there, to make a web, not the whole vault, because that would have been too heavy, but just to make these linear pieces. And so first they make a web out of that, then they come back and they do infill by using what they called ropes and stones to simulate the load of the complete vault while the vault is incomplete. And they would put another stone in here, put that rope over here, hold it in place, and they just keep going and going until they complete all of the groin vaults at the top of the church. Now, all of that is, as you can tell, at every step, challenging. And in the end, they know it's going to stand up. They've built a bunch of Gothic cathedrals before. But the challenge, more than just getting it to stand up, the challenge is to actually build it and to figure out all of those steps in the process and all of those mechanisms for getting materials and people and labor and all of that to work. Exactly the same challenge we have in the construction process today. But it would have been impossible to imagine something like Gothic cathedrals without all of these innovations in building process, which really enabled that cathedral to happen. Okay, see you next time.